and welcome to Miss Bailey's Daily Dose. Today we are going to be learning to identify vertical and horizontal lines of symmetry on 2D shapes. So what is symmetry? So there's a shape here, and if I was going to ask you, do you think this shape has lines of symmetry, what might come into your mind? For some of you, you might think, I can't remember what symmetry is, Miss Bailey. So let's see exactly what symmetry means. So if a shape can be folded in half, either vertically or horizontally, and both halves are the exact same, so they're identical, then it has a line of symmetry. So for example, this rectangle here, there is a vertical line of symmetry because if I folded that rectangle in half, this half is exactly the same size and shape as this half. So that's what we call a line of symmetry, and it's going down vertically. So let's have a look at this shape here. So we know we've got a rectangle and then we've got like a V shape or an arrow, you might say, in between. If we're looking at it vertically, if I split that down the middle in half like this, is this half exactly the same as that half? Have a little think. So do you think that this half of the shape is exactly the same as this half? Your answer would be no, because this part of the shape has the two red lines, parts of the arrows at the end, whereas this one has them rather close together in the middle. So we know that this shape would not have a vertical line of symmetry. However, it might have a horizontal line. So if I erase that one. So horizontally, that means it's split in half across. So if I split it in half here, oh, Miss Bailey's line is not exact. Let's have a little look. Here we go. I can now see that this half is exactly the same as this half. So it does have symmetry, but it has it horizontally rather than vertically. So that would be the full shape. And we can see when it's a full shape, like this one, we can then show that it has horizontal and vertical symmetry. So if I'm going along here, this side and this side is exactly the same. And then I can go across here, and this side are exactly the same. So when it's a big X, you can see it's both got vertical and horizontal symmetry. And when it was just the half of it, the arrow, it only had horizontal symmetry, not vertical. So you can see on letters as well. So you can see the letter A here, it has vertical symmetry. And the triangle here has vertical symmetry. If we tried to have a look at it having horizontal symmetry, we'd have to go halfway and fold it across. Well, I can see already that in this half, the line is straight across, whereas in this half, there's a little gap here, which means it would not be exactly the same, and therefore it does not have horizontal symmetry. Same with our triangle. If I put it halfway through horizontally, you can see that this half is narrower than this half, which is wider, and therefore it doesn't have horizontal symmetry. Do you think that this penguin is symmetrical? So if we put it together, are the two halves exactly the same? So again, I can have a little look at both vertical and horizontal symmetry. So let's start with horizontal, so I'm going across. So here's my penguin, he's about halfway, and I'm going across, and I'm saying, is this top half exactly the same as this bottom half? Well, I know it's not, because if I got a mirror, which is what we usually use when we're looking at symmetry, or if I folded it, I can see there's two eyes and a nose on the top half, but there isn't on the bottom half. And on the bottom half, there's 2 feet, but that's not on the top half. So I know there is no horizontal symmetry there. But is there vertical symmetry? That means splitting it half down the middle. So if I split it in half here, I apologise because my board doesn't go right the way through half. Let's see whether I can do it again. Near enough. So you can see there's an eye on each side, there's one dot for the nose on each side, there's one foot on each side, there's one arm on each side. We're in the middle of the white part of the penguin, so it does have vertical symmetry. Tom says that this shape has vertical line of symmetry because it can be folded in half. Is he correct? So we know that a shape has symmetry not just if it's folded in half. It's if it's folded in half and both sides are the same. So on this shape, you can see it's folded in half, but are both the sides the same? Well, no, they're not, because this side has not only the half of the square, but it has a bit of a rectangle off it as well. This side doesn't have that, and therefore that is not showing vertical symmetry. We could try it with horizontal just to check. So again, I'd go halfway across, which is around about there. And again, you can see it does not have horizontal symmetry either, because if I folded that up to there, you can see this bit here isn't on that side, and therefore it's not got symmetry. So when we find a vertical line of symmetry, like on this arrow shape here, we need to fold the shape vertically. So I'm going to have the shape in a portrait way, so from top to bottom, and then I'm folding it, so I'm going to have this line down here. So I'm not folding it horizontally, so I'm going to get each corner, and if I can, as precisely as possible, fold it so the edges touch. Just like that. And you can see when I fold it that this side looks exactly the same as this side, and therefore I know that this arrow shape has a vertical line of symmetry going down. So from top to the bottom is when we're looking at that vertical line of symmetry. We can also have a look at horizontal lines of symmetry. So if I was wanting a horizontal line, that means from this side to that side, so across, I'm then going to go from top to bottom for this shape, because that's how we do it. So I would go from the top to the bottom in half, and you can see here the difference. So this half has the arrow shape, and this half has a rectangle. So I know that this arrow does not have a horizontal line of symmetry, but it does have a vertical line of symmetry, because when I carve it vertically, I can see that both sides are exactly the same. So you can have a look at different shapes and see whether it has more than one line of symmetry. So for example, if I take the heart, if I want to find a vertical line of symmetry, I'm going from one side to the other. And again, I'm making sure that edges are towards one another as perfectly as possible. I can see here that the sides are exactly the same shape, both sides, and therefore it does have a vertical line of symmetry. If I try it horizontally, I'm going from top to bottom, so I'm folding it from top to bottom. And I can see here the differences. So this side looks like that, and this side has the top of the love heart. So I know that it does not have a horizontal line of symmetry, but again, it does have that vertical line of symmetry because it looks exactly the same both sides. And then you've got the ones like the octagon. So again, vertical line of symmetry side to side. So edges together. I can see there it's exactly the same shape each side, so I know it's got that vertical line of symmetry. And then horizontal, top to bottom. So folding it top to bottom. And you can see here that it is exactly the same shape. So you've got half of an octagon there, and then if I turn it round, it's exactly the same shape. So you can see that an octagon has both vertical and horizontal lines of symmetry. So that's how we can work out whether it has vertical and also horizontal. And you can check on both of them. You can see I've done my lines here. So you can see on this one, we've got both vertical and horizontal lines of symmetry. Same on the rectangle, but we can't on the others, because if I'd had a horizontal line of symmetry here, you can see that this half is not the same as this half, or the same on the triangle. This top half is not the same as the bottom half. And you can see here even further lines of symmetry. So a triangle has 3 lines of symmetry, a square has 4, a pentagon has 5, a rectangle has 4. So not only vertically and horizontally, diagonally, but we're going to go on to that as we go up the year groups. Vertically and horizontally is the first one we want to get our heads around. And you can see the different ones. So now we're going to have a look at letters. This is something that usually comes up on the year 2 SATs test and also in some of the year 3 maths tests that we do within school. So it's changing it from shapes that the children really know, like your 2D shapes here, to letters and seeing whether they can actually understand what symmetry is. So if I take my pen, we're going to have a look at vertical and horizontal symmetry and take each letter at a time. So if we start with the T, we'll try vertical, so from top to bottom. So you can see here that this half is exactly the same as this half. So this one does have vertical symmetry. Horizontal, so we'll try that in a different colour. That's when it's going across. So you can see it doesn't have horizontal symmetry because this top half does not look the same as the bottom half. So I can get rid of that blue line. Let's try vertical symmetry on the J. So if we're going through the J vertically, I can see that it does not have vertical symmetry because this side has the hook round, but this side does not. So I know it doesn't have vertical symmetry. And let's have a little look at horizontal symmetry, so straight across. Again, I can see the top half is not the same as the bottom half, and therefore that J has no symmetry. So I can get rid of that one. Now we'll try the C. So if we go vertically straight down, you can see this half is not the same as that half. If it was the same, this would be filled in like that, so it'd be an O. And then it would be the same, but it's not. So we know it hasn't got vertical symmetry. And then we can have a look if it's got horizontal symmetry. So again, going all the way across. So if we have a look at horizontal symmetry, it does have horizontal symmetry because this half is exactly the same size and shape as the bottom half. So we know that has symmetry, but only horizontally. And now we've got the V. So let's have a little look vertically. So straight down. Yep, I can see that both sides are exactly the same. So it does have vertical symmetry. Does it have horizontal? No. So I can see horizontally, this half is not the same as this half. So I can get rid of that one. But it does have vertical symmetry. So you can have a look here at using different letters. We know that this one does not have any symmetry at all. This one has vertical symmetry. This one has horizontal. And this one also has vertical symmetry. So some of them have vertical and horizontal lines of symmetry, and we looked at those on the octagon. There's some on the rectangle, you can see here on the kite, there's also some as well, and on the letter H. Then you've got shapes like these that have no lines of symmetry, so no matter which way you fold them, they're not the same on either side and therefore have 0 lines of symmetry. And then you've got ones like the hexagon. Yep, just double checking it's a hexagon to counter those vertices. So a hexagon that has 6 lines of symmetry, using the diagonal ones as well. Is this symmetrical? So I want you to have a little look. So it's a hat. See whether you think it's symmetrical. Is it the same on both sides if I were to fold it? So have a little look. What do you think? And we'll have a look in a different colour so you can see. So if I was going to put my lines out vertically, you can see here. And you can see the difference already. So this side has this sort of polished bit, and this side only has a little tiny bit. So that's the first thing that's completely different. Also on this side, you've got 1 bit sticking out, but on this side, you've got almost 2 bits sticking out. So you know that that would not have vertical symmetry. And then again, you can check horizontal symmetry. So going straight across, you can see the top half is completely different to the bottom half. It doesn't have the sticky out bits. The bottom half doesn't have this white section here. So we know that it does not have symmetry. It's not the same when we fold it or halve it. Then we can have a look at this G. So I've folded it here, both vertically and horizontally, to see whether I can find lines of symmetry. So from that picture, do you think that G has lines of symmetry? Have a little think. Does it have a vertical line of symmetry? Does it have a horizontal? So if we do horizontal, that's going across here. You can see this half is completely different to that half. So this half here, if that looked the same as that, it would have this bit on the end, like that. And it doesn't. Therefore, it doesn't have horizontal symmetry. And then if we have a look vertically, so going down here, we can see that this half is all rounded and together, and this half has different shapes and bits in between and spaces. So we know, again, a G does not have any symmetry. Having a look at your worksheets that you're going to be doing today, we're going to be looking at folding shapes and what they look like when they're open. So you know that one half, when it's opened, would then become a hold, so two halves, and what it would look like. So for example, if we were looking at these ones, we can guess what we think the full shape would be. So if one half is a semicircle, the other half would make it a circle. We've got half of a star here, so the full shape would be a star. We've got half of a smiley face here, so the full shape would be a smiley face. Do a big smiley face here. And then we've got half of what looks like a house, so the full shape would be a house. So that's looking at the halves of the shapes, the symmetrical one half, and seeing what we think the full shape is. And then you're going to have some that look like this as well. Now these are the hard ones. This is where it's asking you to draw in the other half of the shape. Now remember, the other half is exactly the same. So the best way to remember it is to actually count the squares on this one. So if it goes 2 squares across on one side, it's got to go 2 squares across on the other side, exactly the same. If it goes 2 squares diagonal on one side, it's got to go 2 squares diagonal on the other side. And that's the best way to work it out. So say if we were going to do this one. If I start with this top line, and I start from here, it goes 1, 2. So it's 2 squares across. So I know the other side has to be 2 squares across. So if I do 1, 2. Oh, doesn't want to know. There we go. You can see it's not the straightest of lines. Sorry, guys. 2 across. And then from there, I'm going to pick another colour. Is it going to work? Oh, it swaps sides, perfect, it knows on there. I'm going to pick another colour from here, and we're going to count down. 1, 2, 3, 4. So if this side goes down by 4, I know from here it also needs to go down by 4. So 1, 2, 3, 4. And then again, I go from here, and I'm counting 1, 2. So from here, 1, 2. And I know that my shape will be exactly symmetrical. Let's try another one. So when it comes to diagonal lines is where it gets a little bit harder. So if we start from this one from the bottom, we start from the outside point and we count 1, 2. I know this one has to go, oh, sorry guys, 1, 2. Try and get it as straight as possible, it's just because of this. Let me put that bit out. Because of this board, it won't let me go exactly straight. There we go. And then from there, I know I'm going up to this diagonal point here. So if I do a little dot there. So I can count from here how many boxes. So it's 1, 2, 3, 4. So I count 1, 2, 3, 4. And I can go straight from there, diagonally, all the way up. And it'll be exactly the same. So you can see there, this half is exactly the same as this half. Same here, so seeing how many squares diagonal it's gone down. So 1, 2. So I know it's going to go 1 to here. And then you can see it's the same amount out. So you can see here, it's 1 square and a half, and you can see here it's 1 square and a half. It's exactly the same. And then the same here. So 1, 2. I'm going to join it up. Oh, sorry. Oh, my board's messing around again. It always does this. So on this bit, if I do it in a different colour so you can see. So you can go from the green the back. And again, you can see 1, 2, and it's 1, 2 in the middle of those bits. So see whether you can have a go on your worksheets at not only deciding whether they have vertical or horizontal lines of symmetry, but then seeing whether you can create the other half of the symmetrical shapes using the squares for your reference. I've put on here some examples of the worksheets just so you can see them. So for example, on the first one, it says draw the vertical lines of symmetry on these shapes. So from the top going down to the bottom if you're drawing it. Then we've got now draw a line of symmetry on each of these shapes. That could be vertical, it could be horizontal. You need to have a little look. Complete the symmetrical shapes just like we've just done. So looking at, oh, if that's 1 square across, and that needs to be 1 square across, and doing it like that. And then match the folded shapes to the whole shapes and see whether you can do those. And some harder ones here. Tick or cross which one shows the correct line of symmetry. And then Caroline has placed a mirror on the vertical line of symmetry. This is what she sees. Can you complete the other half of the shape? So see whether you can now spot the horizontal and vertical lines of symmetry, draw them in, and have them.